Hello everyone, this is Kapsid Simulations and today we are going to discuss about how to visualize using PyMOL 3. So if you have not installed PyMOL 3 in your operating system, you can go check out blogs how to install PyMOL 3 or PyMOL 2. Um, so let's get started. So when you open PyMOL 3 or PyMOL in your operating system, you can see this blank representation of screen, right? So at first, what you're going to do is that you go to the file in the leftmost corner, then you will set a new working directory for your structures. So this is important and crucial because there's two reasons. One, that you know that where your files and everything that you have worked on, all the saved documents in PyMOL 3, where is being saved. This one, the other thing is that you need to assign a lot of time that this is my working directory, this is my working directory. So just to minimize all those tasks, we're going to select the working directory at first and then we will do other works. So let's click on change, then create a folder called a PyMOL or that whatever suits you. I have created a folder called PyMOL. I'm just going to choose it. So now I have selected what is the working directory that I'm going to work on. Now at the rightmost corner you can see this command line button, right? You click on that, you can see that the working directory has been saved very successfully. So there's two ways to actually work on PyMOL. The one is the visualization mode that we are going to discuss today. The other one is a command line interface. That's a little more intermediate stage. I won't recommend that for the beginners. For the beginners, let's get started with the visualization part. So then what you have to do, you have to click on open and you can see there is a lot of structures that I have already saved in my working directory. What I'm going to do, I'm going to select a structure out of it, and if you don't have a structure, don't worry, you can actually go to the let me show you. Sorry, CSV. So what you can do, you can go to the RCSB file database. So over here you have an entry. So if you're working on a mitochondrial DNA or any other CDKs, so you can actually write the name of the protein that you are working on, or even molecules, let's say the nucleic acids also. So if they have the structure of the molecule that you are going to work on, then you just simply download the .pdb structure and then you can actually fetch it inside your PyMOL. So I have already fetched, and the PDB ID that of this molecule is 5IEY. So you can actually go and download it. The other way to download the file is that you go to the command line interface at the bottom line, you type fetch, FETCH, and then the PDB ID that you want to fetch, like say 5IEY. So I'm not going to click OK because PyMOL has one restriction that it won't load two similar molecules. So I have already loaded 5IEY, so it won't allow me to fetch the same molecule. So I can fetch other molecules also, it will represent side by side, but you can definitely do it if you don't want to go to the PDB structure like RCSB file database and then download. So it will solve a lot of problems. Now you can see that there's the red crossings is there and the protein structure is there. There's also another molecule which is a ligand, this one. Okay. So what I'm going to do is that this is a crystallography structure. So the water molecules is not very well represented over here. So I'm going to go to the action button and remove the waters first. Now you have only the PDB structure and ligand molecules. Now mentioning that what is an action button. So in the right panel you can see there's A, S, H, L and C. So A is for action. You see a lot of different commands under the action button, and then there's S for show. So over here you can represent your PDB structure or molecule in a different ways, like a line, stick, spear, cartoon, any representations. H is for hide, so you can hide the structure. anything. L is for label. Label different residues accordingly, because in different publications you have to actually label the molecules, what you want me to, what is interacting over there, and what are the different key residues over there. And the C button is the for coloring. You can color the selected molecules accordingly. So let's say there's another one important thing that I want to mention is that how to select what is the sequence of this molecule. So to do so, you just click on settings. I'm sorry, you click on the display, then there's sequence. You just tick on it, and it will show you the sequence of the entire molecule. And this is the amino acid sequence. Sorry, this is the amino acid sequence, and at the very end you can see that this is our ligand 6AE. So you can actually hide it. There's this shortcut also there in a PyMOL 3, like SEQ at the bottom corner, right? You can see that SEQ. You just click on it, it will show you the sequence. And one more thing, in PyMOL there are different objects, so you work on different objects. Right now it's a one single object in which the protein and the ligands are embedded together, so you cannot work separately on a ligand. So both of these methods have a different aspects, both positive and negative aspects. And right now it's very easier for the ligand to show the interactions and everything. So we're just going to do that first, and then I will show that how to extract it as a different object. So let's click on the PDB action button. Now you can see that there's a preset, right? And under the preset there's again a lot of different ways to represent the molecules. So to be very clear that you can actually show the molecule as a surface, EMS, or ribbon or cartoon structure. But preset is a kind of a wildcard, so you don't actually have to go to the show and then actually hide it. It will do by automatically for you, but it has a limited options, but definitely very useful one. So first I want to click on simple to just go for the ribbon structure. Now you can see that it's all ribbon, and you can clearly see what is the ligand is there, and how it has been placed in the PDB structure. So again go to the action button, go to the preset, and now you see simple no solvent. So definitely there is no solvent because we have removed the water molecules at the very beginning, so we don't have to click on it. There's something called a ball and stick model. You click on a ball and stick. Now you can see that this is the very classical representation, right? You have seen in the books, like this is the ball and stick, and here's our ligand. So I don't want that. I want my ligand and what is the surrounding interactions, the polar interactions around the ligand. So to do so, you click on a technical in the preset only. Now you can see there is a lot of interactions, but these interactions are very cluttered because I don't want the protein amino acid interactions. I just want to, what are the amino acids that are interacting with my ligand, because that's my interest. So to do that, I again click on OK. Let's say I again go to the action button. Let me remove this first. Okay, some issues there. Okay, let's click on action button, then go to the preset, and then you can see that there's something called as a ligand, right? I click on the ligand, it will show me only the interactions that are happening around the ligand, including the ligand. So that's what my interest is, but I don't want to represent it as a ribbon like a simple model. I want it more like a different cartoon structure. So I'm going to do is that I again go to the action button, then again go to the preset, and this time I go on a ligand sites, and under the ligand sites I click on a cartoon. There's a different options are also there which I will show later. Now click on cartoon. now you can see that all the structure, PDB structure, are in cartoon and I can clearly see the interactions, the polar contacts made by the ligand and the PDB. So what I'm going to do, I go click on the zoom button over there in the top and I click on visible all. Let's visible all. It will zoom out everything and make a clear representation where's this ligand and where's the interaction happening. I now again click on the action button. I click on a preset and on the ligand side, and now I don't want it as a cartoon, I want it as a solid surface or a transparent surface. Let's click on a transparent first. Now you can see that it is in a very transparent mode. It tells you the cavity of the ligand, like the cavity that holds the ligand into the protein. So you can actually made it very solid because we have made it as a transparent. So now you can see that I have made it very solid. It is helpful to show that the cavity is there and inside the cavity the ligand is there, and these are the polar interactions made by it. So let's hover to the other options. Now I have made it, but to do a simple visualization, what you need to do is that you go to the action button, then you click on a preset and then click on a pretty. Now you can see that it's in the pretty mode, right? So in the pretty mode, this representation is that it is in a spectrum, like in a different spectrum from in a pure color, a rainbow coloring, and here is my ligand. So at first I have told you that we will show you how to extract the ligand as a different object. So what I'm going to do is that in the topmost corner you can see that there's a molecules, atoms, like, okay. So what I'm going to select is that I click on the molecule, I select on the ligand. Now it has been selected as a different selection, but it's still not a different object, it's a selection. So I click on the action button, I extract it as an object. Now the object is different, like now I click on it and it will act as a different object. So let's rename it, click on rename object. So I'm just going to rename it as a ligand 1. Now you can see that it is there as a different object. So this is very handy and helpful when you are working on a lot of different things. You can actually separate the water molecules out of it as a different object, and just to see representations on how the molecules behaves and everything. So for now, there's one last thing that I want to show you is that how to make publication like images. So you click on the publication and there's something called a with solvent, but we have removed the water at the first, so just click on a publication. Now you can see that this is a publication grade molecules with the interior gray scaling, just to give a very clear representation on a white paper, on a research paper. So after you have made it, you just click on file, then export it as an image. It will again tell you to capture which state you want to capture. You want to capture the current state. You can actually move it just to save in a different states. Now just click on a save image and you can see that I have already installed the working directory, like, so I'm just click on the file name like pn the pdb.img. Okay, just hit enter, it will save the file for you. So that's all for today, and in the next video we will describe the other functions, because there's a lot of functions and we cannot complete everything in one single video. It will take at least 7 or 8 hours just to complete everything. You can also go and check by yourself. There's a very interesting thing happening in a PyMOL 3 and it's called movie making. So it's a very exciting, and we will prepare it in the later videos. So go and check out blogs, our website called kapsids.com, where you can find a lot of different blogs and videos to prepare and to do simulations, MD simulations on molecules. So that's all for today, and see you in the next video.